Hello, this video includes 16 MCQ questions from the midterm exam and their solutions. This video is available through YouTube and is private for students of the Imam Abdul Rahman bin Faisal University College of Engineering Department of Basic Engineering Sciences. Enjoy the video. The first question. F of x equal to x squared plus b when x less than 2. Also, f of x equal to ax plus 3 when x greater than or equal to 2. Find the value of a plus b given the function f is differentiable everywhere. The value is among one of these four options and we have to search for it. Since f is differentiable everywhere as given, it must be continuous everywhere. And since we have less than 2 and greater or equal to 2, we're worried about the jump, so we're going to see if or if not there is a jump. Therefore, we will take the limit of f of x as x approaches 2 from the left. This must be equal to the limit of f of x as x approaches 2 from the right to ensure that there will be no discontinuities. Now, if we take the limit as x approaches 2 from the left, then we will be using this equation, which is x squared plus b. So instead of x, we will put 2. So it's 2 squared plus b. And that will evaluate to 4 plus b. And we take the limit of the function, but this time as x approaches 2 from the right. So we will be using this value, okay? And that will be equal to 2a plus 3. Now that we have these values, if these values are equal, and they should be equal for the function to be continuous at 2. So we will say 4 plus b equal to 2a plus 3. Now we will just do some mathematics. Since we're looking for a plus b, let's add a to both sides. If we add a to both sides, we're going to get a plus b plus 4 equal to, instead of 2a, will be 3a plus 3. Now that we have these, we have to move the 4 to the other side. So if we do so, we'll get a plus b equal to 3a minus 1, because when we move 4, it will be negative 4 plus 3, we will be end up with negative 1, which is right here, minus 1. Now that we have these values, from the given answers, a plus b equal to 11 implies a equal to 4 and b equal to 7. The other options do not satisfy the equation a plus b equal to 3a minus 1. Therefore, the answer is B. That's it for this problem. Let's go ahead to the next. For the next question, if y equal to square root of x all raised to the power x, then y prime of 2 equals to one of these values. Y prime of 2, that means find the derivative of y and then plug in for x the value 2. Let's get going now. We must dismount the exponent x by taking the log of both sides. Anytime the exponent is a variable, it's always recommended we use ln on both sides. So let's go ahead and do so. Ln of y equal to x, ln of square root of x, which is equal to x over 2 ln of x. Why? Because square root of x is x to the power half, and we took the half outside. Now we take the derivative of both sides, derivative of the left hand side, derivative of the right hand side. And that will give us the following. Derivative of the left hand side is 1 over y dy by dx, because y is the function of x. So this is chain rule, 1 divided by y dy by dx should be equal to derivative of the right hand side. Right hand side is this. So derivative with respect to x will give us the first term. Derivative with respect to ln will give us the second term, which is this. Ln of x, its derivative is 1 over x. So the x's will cancel. That is, dy by dx will be equal to y, because we have to multiply y by whatever in between these curly brackets. So we multiply y. So we have y, and then this is the inside values, which is half of ln x plus half. Where is the half coming from? Because we have x cancels x and we have plus half. Now all we have to do is just follow the math. So we have to solve for dy by dx, okay, which is equal to y prime of x, and that's equal to, we said y, but then y is nothing but the square root, which is this. Y is nothing but the square root of x to the power x. So instead of y, we replace its value, and then between the curly brackets, we remain the same. Now we have to find y prime of x. So y prime of x equals 2, we have to plug in for every occurrence of x the value of 2. So square root of 2 to the power 2, and then between the brackets the same values. Square root of 2 to the power of 2 will give us 2. So we can just take the 2 and multiply it both terms here. So 2, and then we have half here, plus we have half here. So we take the 2, it will take care of the halves. We will be ending with ln of 2 plus 1, and that is the correct answer, which is choice D. For this problem, if y equal to x sine inverse of x plus square root of 1 minus x squared, then dy by dx equals to one of these values, and we have to search for it. Dy by dx, which is derivative of the left, equal to d by dx of the value between the two curly brackets, which are the two terms of the function. So derivative of the left equals derivative of the right. We didn't execute derivative, we just said derivative of the right hand side, and this is right hand side. Now we can see that derivative is linear, so derivative of the sum is the sum of the derivatives. So we will take it one at a time. The first term, its derivative will be two terms, because we have to do the derivative of the first multiplied by the second, and then the derivative of the second multiplied by the first. And that will give us 1.1 multiplied by sine inverse of x, derivative of the first, plus x is kept, and then derivative of the second, which is sine inverse of x. Since we do not know the derivative, we're going to delay how to find the derivative of this one later. But then we have to do the derivative of the second term of the function, which is derivative of square root of 1 minus x squared. So d by dx of this. Now this equation is extremely important, and that's why we gave it a value of 1, equation 1, to refer to it later on. We will use calculus to save us from the derivative of sine inverse of x. And in calculus, we will use trigonometric. So we will let v equal to sine inverse of x. One of the tricks of calculus is that we have to do sine of both sides. So sine of the left-hand side will give us sine v, and sine of sine inverse of the right-hand side will give us just x. Hence, sine v equal to x. We will use the triangle for sine v equal to x. Here is the triangle. This is right angular triangle, and this value of this angle is pi, is the value of this angle is V. So sine V will be the opposite divided by the adjacent. So sine V will be equal to x. So this is consistent with sine V equal to x. So this triangle comes handy. Now we have 1 and we have x, so this will be square root of 1 minus x squared. Now, since we put v equal to sine inverse of v, let's do the derivative of both sides. So derivative of v is dv by dx. Derivative of sine inverse of x is d by dx of sine inverse of x. Also, we have sine of v equal to x. Let's get derivative of sine of v. D by dx of sine of v should be equal to dx by dx. If we execute this derivative with chain rule, so derivative of the outside cosine v, derivative of the inside dv by dx. Derivative of the right hand side is equal to 1. So this implies dv by dx equals to 1 over cosine v. All what we did is we divided by cosine v on the left hand side and the right hand side. So we have dv by dx equal to 1 over cosine v. Now we have to get rid of cosine v because we just entered v as a catalyst. So now we have to use trigonometric to save us, eliminate v's. From the triangle, cosine v is equal to 1 square root of 1 minus x squared. Cosine v is the adjacent divided by the hypo. That will give us what we said over here, square root of 1 minus x squared. So instead of dv by dx equal to 1 divided by cosine v, now it's equal to 1 divided by square root of 1 minus x squared. Now that we have all the puzzle components of the first term, let's get the second term. The derivative of the second term, d by dx of square root of 1 minus x squared equals to negative 2x divided by 2 multiplied by square root of 1 minus x squared. From equation 1, we can conclude the following. Remember, I said equation 1 is important, so let's go term by term. The first term, 1 multiplied by sine inverse of x, remains the same. So we're going to go ahead and display the answer. So dy by dx, which is this one, and then let's move all the way to this equation, okay, and then compare it over here. So the first term is the same as the first term, it remains the same. Now the second term is x multiplied by the derivative of sine inverse of x. But we just said that the derivative of sine inverse of x equal to 1 over square root of x, the square root of 1 minus x squared. So 1 divided by square root of 1 minus x squared is the derivative of sine inverse of x. So instead of derivative of sine inverse of x, we put here x multiplied by 1 over square root of 1 minus x squared. And that is the second term of the derivative of the first term. Now the derivative of this term, the second term of the function, is negative 2x divided by 2 multiplied by 1 minus x squared. Now that we have all of these values, we can say this is equal to, and then sine inverse of x, which is the first term, and we can cancel the 2 with the 2. So we have in green the first, which is x divided by square root of 1 minus x squared, minus in purple we will have just x divided by 1 minus x, all the square root of that, 1 minus x squared. So we can see that these two will cancel each other, and the end is that dy by dx will be equal to sine inverse of x. And that is option number B, and that ends up this. Let's get to the For the next problem, the equation of the tangent line to the curve y equal to 2 divided by x at x equal to 2 is, and we have to find that among these options. So we have 4 options. We have to identify the correct answer. First, we will find the derivative of the curve equation and then evaluate it at the point 2, 1. And where did we get the value of y? Because we have x equal to 2 given, so we have to plug in 2 here, and that will give us y equal to 1. So the point will be 2, 1, and we use this one to find the slope of the tangent at this point. So here we go. First, we find the value of y when x equal to 2, which we did, and this is the proof of it. It's equal to 1. Now, y prime of x is the derivative of 2 divided by x, and that's also represented by dy by dx equals to negative 2 divided by x squared. This implies that y prime of 2, we're plugging in for x2. Y prime of 2 equals to negative 2 divided by, we evaluate by plugging for x2, we will get 2 to the power 2, and this ratio will give us negative 0.5. Now that we have negative 0.5 at that point, then the general formula for the equation of linear function is y equal to mx plus b. Therefore, y equal to mx plus b implies that 1, which is the value of y, equals to negative 0.5, that is the slope, and then x equal to 2 plus b. We're just looking at these one term at a time. We can see that we can figure out b to be equal to 2, because 2 times 0.5 is equal to 1, and this negative 1, so we'll take the 1 to the left side, so we'll have b equal to 2. And b equal to 2 implies the equation, if we go term by term, we can see that y equals to m, which is negative 0.5 multiplied by x plus b, which is 2. And that is the equation that we are looking for. And from the choices, it will be choice number C. For this question, we have to find f, given f of x equal to 1 minus sine x divided by 1 plus sine x, then we have to find the derivative of the function and evaluate it at pi over 2. And the answer is one of these options. We will use the quotient rule for solving this problem. We can see the quotient rule states the denominator will be squared, which what we did, and then in the numerator we will have the denominator multiplied by derivative of the numerator. Derivative of the numerator will be cosine x, but there is a sign which is negative, so we'll keep the negative, multiplied by the denominator, which is this, and then we should subtract the derivative of the denominator multiplied by the numerator. Derivative of denominator is cosine x, so the sign will stay the same, multiplied by the numerator, which is 1 minus sine x. Now we have the values, and now we have to let the math work for us. So this is equals to, we have to multiply negative cosine x by 1 and give us the first term, and then we have to multiply negative cosine x by sine x, that will give us negative cosine x sine x, and we go to the other side. Cosine x, we have to multiply it by 1, but we have to keep the value, the sign over here, so minus cosine x, and then we have to multiply negative cosine x by negative sine x, and that will give us positive cosine x sine x. We can see that there is cancellation, especially we have cosine x sine x, and this is added, so this is positive, and we have cosine x sine x, and this is subtracted, which is negative, so this cancels this. We will end up with negative cosine x 2 times, so negative 2 cosine x divided by 1 plus sine x square. Now we have to go to the next step, which is just plugging for every occurrence of x pi over 2. So f prime of pi over 2 equals to negative 2 cosine of pi over 2 divided by 1 plus sine of pi over 2 whole square. But cosine pi over 2 is 0, pi over 2 is 0, divided by 4, it doesn't make any difference. That's going to give us 0, so the correct answer is 0, and that is option number D. For the next question, if y equal to x e to the 2x, then find y double prime of 2. That is, find the second derivative of the function evaluated at 2. And the answer is one of these options. For this problem, we use the product rule. For y of x equal to x e to the power 2x, y prime of x equals to the derivative of the first will be equal to 1 multiplied by the second plus the derivative of the second, which is 2 multiplied by e to the 2x. So it will give us 2x e to the 2x. So now we have the first derivative. To get the second derivative, we will do derivative of the derivative. So the derivative of the derivative, or y double prime of x, equals to 2 e to the x, because that's the derivative of the first term. It will give us the 2, so it will be 2 e to the 2x, and then product rule over here. So to start with, we'll take the derivative of x, so we'll be left with 2 e to the 2x, which is this one, plus now we leave the x and we do the derivative of e to the x. That will give us 4x 2 e to the 2x, and this will be equal, if we take e to the 2x as a factor, we will have 2 plus 2 plus 8 inside, so e to the 2x, and then inside we have 12, and that's equal to 12 e to the 2x, and that is the correct answer. And from the options, it will match B. Next, if x cubed minus x plus 3 less than or equal to f of x, and f of x less than or equal to 3x squared plus 3, then limit of f of x as x goes to 3 equals to one of these values. And to find the correct one, obviously we're sandwiching f of x between two functions. So let's go for this comment and then we will proceed. For this problem, we use the sandwich theorem. If the sandwiching limits, that means the limit of the left-hand side and the limit of the right-hand side. If the sandwiching limits are equal, then the sandwiched function, which is f of x, the sandwiches function's limit will equal to the sandwiching limits. And we can explain that mathematically now. If we take the limit on the left-hand side, and the limit on the right hand side, and these two limits are equal, then the limit of f of x will be equal to the limits of both of this one and of this one. So let's go for it now. If we plug in for every occurrence of x before this function and after this function, we will get the following. In the left, we will get, instead of x cubed, we will get 3 to the power 3 because we're plugging for every x 3. And then instead of negative or minus x, we'll get minus 3. And on the right hand side, we also do the same. Instead of 3x squared, we'll have 3, and then instead of x, we'll put 3 squared. And if we do the math, we can find that now we have the value of 27 on the left, less than or equal to limit as x goes to 3 of f of x, and less than or equal to, f of x is less than or equal to 27, which is also this value. So we can see that the limits, the outer limits are equal. So the limit of the function f of x as x goes to 3 must be equal to 27. And that will lead us to the right answer, which is option B. The question is as follows. The function f of x equal to 6 divided by 5 minus x multiplied by 4 plus 2x for x less than 1, and the function is also defined by the following: 1 over 2 square root of x for x greater than 1. Then the number of points of discontinuity equals to one of these values, and we have to analyze to find out the correct one. So the denominator for the branch with x less than 1 has x equals to -2 and x equal to +5 as points of discontinuities, because this will give us 0 if x equal to 5, and this will give us 0 if x equal to -2. However, the branch with x greater than 1 has no point of discontinuity, because the only value that's going to give us discontinuity is x equal to 0. But for this branch, x is greater than 1, so we're going to ignore that. So we can just conclude that we have exactly 2 points of discontinuity. This is our conclusion: 2 points of discontinuity, and that makes option A as the answer. Next, we'll have to find the limit as x goes to infinity of this function. And to do so, we have to identify the correct answer if we do so. For this problem, we have to use the conjugate. So limit as x goes to infinity of the function will be equal to limit as x goes to infinity of the function divided by 1. But then we're multiplying the numerator and denominator, each we're multiplying by the conjugate. And if we do the math, this is what we will be getting. We'll be getting on the top 4x squared plus 4x minus 4x squared. It's very clear that the 4x squared will cancel each other, divided by the conjugate. So let's go with the math now. So we could rewrite the limit as follows: 4x squared plus 4x minus 4x squared divided by, we're taking 4x squared from the square root over here. So when we take 4x squared we will get outside 2x, but then over here we will have a remainder of 1. So 1 will be remaining in the position of 4x squared because we took 4x squared outside. Plus we have 4x. So when we took 4x squared outside, we will be left with 1 over x for the second term under the square root. And that is plus 2x. So we can see that we have cancellation on the numerator. So 4x squared cancel each other. So we'll end up with 4x on the top. And on the bottom we have 2x. So we can get rid of the two x's. The one in the top and the one in the bottom, they can cancel each other. So we can take the limit of 4x divided by 2x, and then between the curly brackets, or we have square root of 1 plus 1 over x plus 1. Like we said, we can cancel the x in the numerator with the x in the denominator, and we'll end up getting 2 divided by square root of 1 plus, now we evaluate and we plug in for every occurrence of x infinity, and there is only one occurrence. So 1 plus 1 over infinity, that is equal to 1 plus 0. So square root of 0 is equal to 1. So 1 plus 1 equal to 2. So the numerator divided by denominator equal to 1. And 1 will be the correct answer, and that will be choice B. Next, our function is as follows. We have to find the limit as x approaches 3 from the left of this rational function. In the bottom, we have the absolute value of x plus 3. And that tells us that this function has two branches. And we have to pick up the limit as x approaches 3 from the left from these 3 options or 4 options. To do so, let's just make some statements. Number 1, there are 2 branches for this problem because of the absolute value. The branches are as follows. For the first branch, x should be greater than -3. The limit exists since we can reach x equal to 3 from this branch. For the second branch, x should be less than -3. Hence, x cannot reach 3 because it is less than -3. Therefore, we have to find the limit for the first branch. It then follows that limit for the first branch as x goes to 3 from the left, we have to plug in the values over here. But before that, we could also go ahead and factor the top. If we take the same limit and factor the top, this is what we're going to get. And from this, we can cancel x plus 3. So we'll end up with just x minus 4. And we have to find the limit as x approaches -3. And that's going to give us 3 minus 4, which is equal to -1. And that is the correct answer. And in the options, it will be answer D. For this question, we are asked to find the limit as x approaches -2 from the left of this function. And the answers are over here. We have to pick up the correct one. Let's go ahead with the limit as x approaches -2 from the left of the function. If we plugged in for every x its value, which is -2, we will get in the numerator -6, and in the denominator we'll have -2 multiplied by, between parentheses, negative 2 plus 2. But then we can see that negative 2 plus 2 will give us an extremely small value, extremely small value, and that value will be almost 0. So when we multiply it by negative 2, it's not going to make any difference. It will also keep us with 0 in the denominator. So negative 6 divided by 0 is going to get negative infinity. So one more time, since negative 2 approach from the left plus 2 will give us an extremely small negative value, it follows that the limit must be equal to negative infinity. And the value inside will be extremely small but negative, and the negative will be cancelled with the 2 outside. It has a negative 2. So we'll have a positive value, which is extremely small but positive value. And we have in the numerator negative 6. So that will end up giving us the limit equal to negative infinity. And that's the correct answer. The next question is as follows. Which of the following statements is true about the curve y equals to this rational function? The options are given over here and we have to identify the correct answer. To do so, first we have to look for the horizontal asymptote, and for which we should take the limit of the rational function as x goes to positive infinity, negative infinity, and both in some cases. So luckily we have a polynomial on the numerator and a polynomial on the denominator, and the degree of both polynomials is the same. On the top, the largest degree is 2. On the bottom, the largest degree is also 2. So we can find the horizontal asymptote by inspection, by just taking the ratio of the coefficients of the terms with the largest exponents. In this case, we 4 divided by 2, and the answer will be equal to 2. But we can prove this one also by dividing the polynomial on the numerator by x squared and the polynomial on the denominator by x squared. And that will give us over here 4 plus 5 divided by x divided by 2 minus 2 over x squared. Now if we take the limit as x goes to positive infinity or negative infinity, we will figure out that 5 will diminish, become equal to 0, and 2 over x squared will also diminish, becomes 0. So what will be left to is 4 divided by 2, which is also equal to 2. So we can conclude that the horizontal asymptote is at x equals to 2. Let's go ahead and look for the vertical asymptote. To find the vertical asymptote, we have to look for the zeros of the denominator. We can see that the denominator is 2x squared minus 2. We have to equate this to 0. That will give us 2x squared minus 2 equal to 0, which will end up as x squared equals to 1. And when we take the square root of both, we will find out that x will be equal to 1 or x will be equal to negative 1 for the denominator as zeros. And from that, we can conclude that the denominator offers us two values for which it has zeros, x equal to plus 1 and x equal to minus 1. Now we can summarize that the horizontal asymptote is found at x equal to 2, and there is a vertical asymptote at x equal to 1, and also a vertical asymptote at x equal to negative 1. and this will help us identify the correct answer, which is option D. The next question is as follows. What are the domain and range of the function f of x equal to x to the power 4 minus 6x squared plus 9 divided by x squared plus 4? These are the options that we have to pick up from the correct answer, and there is only one correct answer. To start with, we'll go with the denominator. The denominator is equal to x squared plus 4. Obviously, the values are always positive. So this denominator will always have a positive value. That means there is no zero. There is no zero in the denominator. Therefore, the domain is the set of all real numbers, which can be represented by negative infinity to infinity. To find the range, we have to examine the numerator. So the numerator is x to the power 4 minus 6x squared plus 9. This could be rewritten as x squared minus 3 all squared, and this implies that the function f of x evaluates to 0 only for the value of x equal to positive square root of 3 and negative square root of 3. Then the range will be from 0 included all the way to infinity. 0 is included by the fact that any of these two values will give us f of x equal to 0. That's it for this question, and obviously the domain is negative infinity to infinity, as we said, and range is from 0 to infinity including 0, and the correct answer is C. Which of the following equals the slope of the line 6x minus 5y equal to 5? The general equation for a line or a linear function is y equal to mx plus b, where m is the slope and b is a constant. Therefore, we have to rewrite the equation as follows. 6x minus 5y equal to 5 is same as 5y equal to 6x minus 5. Since 5y equal to 6x minus 5 can be solved for y as follows. Y equal to 6 over 5x minus 1. It then follows that y equal to mx plus b is equivalent to 6 over 5x minus 1. And this implies that the slope m is equal to 6 over 5. One more time, we can see that we shuffled the values around and we ended up the same formula. This is y, and this is the slope, and this is x, and b is negative 1. So the answer is 6 divided by 5. We have the following question. Find the equation of the graph obtained by shifting the function y, which is also represented by f of x, equals to x minus 3 all raised to the power 2 minus 1 up by 2 units and shifting it right by 2 units. Shifting up by 2 adds 2 to the function value. Therefore, f of x plus 2 is equals to, open parenthesis, x minus 3 close parenthesis square minus 1 plus 2. So in purple is the displacement. So we have plus 2 here, and we end up canceling the 1, and that will be, open parenthesis, x minus 3 all square plus 1. This is the first shift. The second shift is to shift to the right. The value of x will be changed. So shifting the function right by 2 units requires subtracting 2 from x, which is the parameter of the function f of x. Since f of x plus 2 equals 2, we have over here x minus 3 square plus 1. This x is the one which is involved in the shift. Then subtracting 2 from the parameter of the function f, we get the following. So we see here 2 is subtracted from the function x value. So x minus 2, and then the rest is the same, minus 3 all raised to the power 2 plus the 1 which is the shift up. That's the result of the shift up. So if we do the math, x minus 2 minus 3 will be x minus 5 all square plus 1. And this is the correct answer. Hopefully the last question. And it is about determining the interval on which the function's graph, which is given right here, is increasing, constant, and decreasing. And here are the options to pick up from. And we will proceed as follows. From negative infinity to negative 2, the function is decreasing. Sure enough, since this end is open, that means we have to consider the value from negative infinity to negative 2, because this is negative 2. Each unit is a block. So this is 0, negative 1, negative 2. So from negative infinity to negative 2, it's clearly the value of f of x is decreasing. From negative 2 to positive 2, the value of f of x is constant. And from positive 2 to positive infinity, the value of the function is increasing. So in conclusion, the correct answer is D, which says decreasing on negative infinity to negative 2, increasing on 2 all the way to positive infinity, and constant on negative 2, positive 2. That's it for now, and good luck on your future assessments.